This is section 8.4 in pre-algebra having to do with volume. Now in the last section we talked about area, and area was two-dimensional. It was length times width. There were two measurements that we multiplied. Volume is considered three-dimensional because we're multiplying three numbers here, length times width times height. Now when you look at this rectangular solid here that I've got, you notice that if we want to find the volume, we want to find out, let's say you're going to fill this with water. How much water can we put in here? So this is the length and our width and our height, and we multiply all three of those together in order to find the volume. So for example, if this particular box or rectangle was 6, 4, and 3, we would multiply 6 times 4 times 3, which would be 72. So the volume of this would be 72, and if this were inches, we'd have 72 inches cubed because we multiplied three numbers together to get our answer. So volume is going to be measured in cubes, cubic feet, cubic inches, and we just put a 3 up there instead of a 2 like in square inches. Alright, so let's look at some of these examples. Let's look first of all at the volume of a cylinder. So let me get this out of our way. And let's get a cylinder up here. So the volume of a cylinder, basically that means how much pop can I put in a pop can. So here is the formula in order to find the volume. We take pi times the radius squared times the height. So if this is 5 and this is 7 inches high, our volume then would be pi times our radius squared, 5 squared, times our height, which is 7. So you'd multiply those together. And again, we have three numbers we're multiplying, and we're going to end up with, say, if this were in inches, we'd end up with a volume of so many cubic inches. If we're looking at example 2, when it talks about a drinking straw, the volume that can hold is going to be the same, pi r squared h, even though it doesn't have a bottom or a top and you're not going to put anything in it. If it did have a bottom and a top, how much liquid could it hold in that straw? So again, we take our volume, or our radius, which is 0.125, put in for r, and we take our length, which is 6 inches, and put that in there, and we do the math and find out the volume of that. So what I have here for example 3 is the volume of a cone, which is basically an upside down ice cream cone. And the formula for that is right here. So not too difficult of a formula, just plugging numbers in. So let's go ahead and do this one right here that they're giving us as an example, number 3. They're telling us that our height is 5, our radius is 3, and that's all we need. So volume equals 1/3 times pi times our radius squared. In this case it's 3, so that would be 9, and our height is 5. So we've got all those numbers there, we multiply those together and we get 47.1 cubic centimeters. So centimeters with a cube up there. Okay, notice we multiplied more than 3 numbers, so it doesn't necessarily mean that that's how many numbers you multiply, especially when you're getting out of the idea of rectangles and or cubes and rectangular solids and that kind of thing. When you get to some of these odd things, sometimes you're multiplying a whole bunch of numbers, but either case, because you're finding the volume, it's going to be in cubics. Alright, so let's look at a last one, which is the volume of a sphere. So the volume of a sphere, let me get a sphere up here for you to look at. Okay, so there is a sphere, and there is the formula in order to find the volume of that. So notice that our radius is cubed. So let's say that our radius on this is 3. So we're going to take 4/3 times pi times our radius cubed, 3 cubed. So this means 3 times 3 times 3. It means we're going to multiply 3 times itself 3 times and get 27. So we're going to take that and put in here for r cubed, multiply it by 3.14, and then multiply it by 4, and then divide it by 3. And that'll give us the volume of that cube. So this is example 4. So we've got a hemisphere sitting on top of a right circular cylinder, and my drawing or my picture that I have of that page is kind of askew. It's not really exactly like the book does. It's kind of crooked, but oh well. So they want us to find the volume of the volume enclosed. So it doesn't matter if it has a top and bottom. We just need to know if we were to fill that thing up with liquid or water or whatever, how much room is it going to take up. So we're going to find the volume of the cylinder. So volume of the cylinder. So this part down here. And then we're going to add the volume of the hemisphere. Okay. So volume of a cylinder is pi r squared h. This is from your book. That's a formula that they give us. And then we're going to add the volume of the hemisphere. So the volume of a sphere we already found is 4/3 pi r cubed. But we're not interested in a sphere. We're interested in half of one. So we're going to take half of it when we're done. So this is going to be 3.14 times our radius squared times our height, and then we're going to take 1/2 times 4/3 times 3.14 times again our radius, but this time our radius is going to be cubed. So radius cubed is going to be 5 times 5 times 5, which is 5 times 5 is 25, times another 5 is 125. So we're going to do the math, add those together, and have our volume of that. I guess it kind of looks like a bathroom trash can or something. Alright, anyway, problem sets. They give you a whole bunch of pictures here. They're doing pretty much the exact same examples that I showed you with cylinders and bathroom trash can pictures and upside down ice cream cones and that kind of thing. And then the story problems are very, very similar. I guess I want you to notice, and I'll just put that information on here. Notice number 21 and 22. They give you an engine. The size of an engine is the measure of the volume. Okay, so if you have an engine that's a 6.2 liter or a 700 cc, it's called displacement, and that's how much volume, if you were to add up the room that each of the cylinders takes up, add up. If it's a 4-cylinder, you're going to take the volume of each one of those cylinders, add them together, or multiply it by 4, and that'll tell you the displacement, or how much room that piston is going to travel when it goes up and down in that cylinder. And so that's the gives you the idea of the size of the engine. So to calculate the size of an engine is to find the volume of a cylinder and multiply by the number of cylinders, like I just said. The size of a cylinder is given as a bore size or diameter, and a stroke size, which is the height. So if a cylinder, and I'm just going to draw a real basic cylinder like this, and it's just going to look like a pop can, and the bore size is how far it is across here. The bore size and the diameter is the same thing. The stroke is going to be this length from here to here. The stroke is the distance that the piston goes from its bottom dead center to its top dead center, and so that is going to be the height. So they're going to use the word bore and they're going to use the word stroke instead of the words diameter and height, but they're the same thing. All right, so they say find the size of an 8-cylinder Chevy big block engine with a bore of 4.25 and a stroke of 3.76. Okay, so they're asking you to find the volume of that cylinder. And if you remember, let's see, where was it? The volume of a cylinder is going to be pi r squared h. So your bore size is your diameter, and you remember that your diameter is twice the radius. You're going to take half of this and square it. So once you take half of that and square it, you're going to multiply it by the height, which is 3.76, and multiply that times pi. And that will give you the displacement or the volume of one of those cylinders. Well, the book says there's 8 of them. So we're going to have to take the answer to this and multiply it by 8 in order to find out the size of that engine. Now it's going to be an 8-cylinder big block, so it's going to be quite a large number in the several hundreds, and that will be in cubic inches. So when you're done, you're going to write inches cubed, and that'll give you the size of that engine. Okay, so other than that, they shouldn't give you too much trouble. I do want you to notice, though, for 23 through 26, it gives you a triangular pyramid and finding the volume. Notice they give you in the explanation the volume of a triangular pyramid is V equals 1/3 BH, where B is the area of the base. So you're going to find the area of the base of each of those pyramids, multiply it by its height, and again, height is that 90-degree angle there. This is going to be the height. It's not this there. This is not the height right there. That's called the slant height, which we'll get into later. But you want this height right here, and then multiply that by 1/3, and that'll give you the volume of a pyramid. So that's it for Chapter 8.